Hi folks, welcome to 3.7 part 1 and the second video in that section. And so in this section, we're going to talk about graph transformations of the reciprocal function. And I know that in the what we know, I had said a reminder about the general graph transformation form, which looks something like this. Okay, but for us, we're actually only going to focus on 3 of those graph transformations, all right? So in particular, we're going to focus on our A. We're going to focus on our C and D. So our C, our C and our D. Okay, so those 3 are the graph transformations we're going to focus on here. We're actually not going to worry so much about B. The only reason for that is it's just a little bit hard to see what's happening with the stretches and the shrinks vertically and horizontally here. So we're just going to focus more on shifting things left and right as well as up and down. Okay. So as just a quick reminder, all right, our D graph transformation, let's start at the bottom here. The D is a vertical translation, or we also call that a vertical shift. Okay, so vertical translation or vertical shift. And if in our equation we see a plus D, then that moves our graph up, whereas a minus D moves our graph down. Okay. And working our way backwards, our C does something similar, except instead of a vertical translation, it is a horizontal translation, or we can also say a horizontal shift, okay? Now, the horizontal stuff is the one that's sort of confusing. So if I see a plus C in the equation, it actually moves to the left. And if I see a minus C in the equation, it actually moves to the right. Okay, so that's one. Maybe we put a pink star next to this, that we just have to be really careful about that. All right. And for our last graph transformation that we're focusing on, I know I said earlier that it's really hard for us to see the vertical stretches and shrinks and the horizontal stretches and shrinks. And so what we're going to be focusing on here is positive A is going to mean that our graph looks something like this. So wherever our asymptotes are, our graph is going to look something up here and up here. So if you remember the quadrants of our grid, it will be in quadrant 1 and quadrant 3 if we have a positive A. But if we change one little thing and we make this a negative A now, all right, so we change this positive A to a negative A, then it actually changes our branch location. So we're not in quadrant 1 or 3 anymore, but the reflection will now take this one and flip it to quadrant 4. All right, so now we're in quadrant 4, and it takes this branch and reflects it up to quadrant 2. All right, so quadrant 2. So we're not really focusing on stretching and shrinking. We're more thinking about where are the branches? Are they in quadrant 1 and quadrant 3 or quadrant 2 and quadrant 4? Okay. So let's practice. All right, we're going to do a few examples and then call it a day. So we have our f of x equals 1 over x minus 4. Now I notice that this minus 4 is a D value. So the only graph transformation that's happening is we are shifting down 4 units. Okay, shifting down 4 units. That's the only thing that's happening here, okay? Now, while we're at it, let's take a look at example 2. Would we say that example 2 is shifting up or down by 6? And I hope we would not. I hope we would recognize that this plus 6 is actually, the C value, all right? And a plus 6 means we're shifting left 6 units, okay? We're shifting to the left 6 units. So now let's think about drawing a picture for each of these, all right? So we're gonna list out our transformations, we're gonna draw our pictures, and then we're also gonna label our horizontal and vertical asymptotes, okay? All right, so let's get started with our horizontal asymptote. In example 1, if I move something down 4 units, then I'm actually moving the horizontal asymptote down 4 units, all right? But if I'm moving something left or right, the horizontal asymptote actually stays where it is, okay? So while we're here, let's write these equations. The first horizontal asymptote will be y equals -4, and we can abbreviate this as HA for horizontal asymptote. And in example 2, our horizontal asymptote is y equals 0, all right? Now let's think about that vertical asymptote. So in example 1, if all I'm doing is moving the picture down 4, then my vertical asymptote actually stays exactly where it is. But in example 2, if I shift the whole thing to the left 6 units, now my vertical asymptote is over here. All right, so let's label those. Vertical asymptote, x equals 0. And this one, the vertical asymptote is x equals -6. Okay. Now, I don't see a negative a in either case. That means that my branches will be in the top right and the bottom left. So top right, bottom left, okay? So the first branch will be over here, and the second one will be over here. And this picture is detailed exactly as much as we need it to be, okay? And for example 2, same thing, we're gonna have our branches in the top right and the bottom left, all right? Cool. Now let's take a look at some other examples. All right, and we're going to do the same thing. All right, so if you want to go ahead and work through examples 3 through 6, now is a great time to pause your video. You can come back and I will explain all these things to you. And if you haven't actually paused a video to try some things on your own yet, I would encourage you to do that, okay? It's so important that we give ourselves the time to think and try and make mistakes in a safe environment, you know, sometime before the test day. All right, so let's take a look at example 3. What's happening here? I see a negative A and I see a C value. So for this one, I want to say reflect over the x-axis because I have the negative A. And then I also want to say shift to the left 3. Okay, so let's draw that. Let's see what that looks like. If I shift to the left 3, I am not changing my horizontal asymptote. But I am changing my vertical one to be somewhere over here. Okay. And now my branches, instead of being top right and bottom left, right, because of the reflection, now it's going to be top left and bottom right. Draw a branch in here. I'll draw a branch in here. All right. before we leave this question, let's ask ourselves, does this get full credit? And I'm going to go ahead and say, not quite. All right, we've listed our transformation, we've drawn our graph, but we have not written the equations for our asymptotes. So vertical asymptote is x equals -3, and our horizontal asymptote is y equals 0. Okay, so I want to see those equations there. That gets us full credit. All right, let's move on to example 4. I see a negative again. There's my negative a, and this time I don't see a c value, but I see a d value. So I am going to reflect over the x-axis. That is one of the transformations. And then that +7 is a shift up by 7. Okay. So we've almost set out for ourselves what we're going to be drawing. Okay. If I shift up by 7, that horizontal asymptote goes up by 7. But I'm not going side to side any, so my vertical asymptote stays where it is. Now, if you forgot to write your asymptote equations last time, now might be a good place to write those in, right? So we don't forget. Vertical asymptote of x equals 0. Horizontal asymptote of of y equals 7. All right. Now, my reflection over the x-axis means that in my new sort of coordinate, I don't want to be top right and bottom left, but I actually want to be top left and bottom right. Okay, so here's one branch, here's another branch. Presto bingo, we've got full credit. Okay, all right, 2 more examples. Let's take a look at example 5. All right, so for example 5, we do not have an a value, or we have an a value, that's 1, but we do have a -2 for the c and a +3 for the d. So all that does is shift the graph right 2 units and shift the graph up by 3 units. All right, so we're shifting the graph right and up. So what does that change? Our horizontal asymptote is now going to be up at y equals 3, okay, because I've moved everything up 3. But our vertical asymptote is now going to be over 2, right? And in particular, this vertical asymptote is at x equals 2. Now there's no reflection, so I'm going to go ahead and assume top right and bottom left. So I've got one branch and I've got the other branch. Okay. All right, last one. We're throwing all 3 transformations in there just to see what that looks like. We've got our negative a, which is our reflect over the x-axis. All right. What else do we have? We have a +2, which means a shift left 2. And last but not least, we're moving things. So shift down 5. All right. So how does this change each part? Well, shifting down by 5 means my horizontal asymptote is now at y equals -5. Shifting to the left 2 means now my vertical asymptote is at x equals -2. Last piece, where do I put my branches? It's a reflection, so I've got to put it in the top left and the bottom right. And let's sketch those in. one here, and one here. All right. So folks, that's just a new application of our graph transformations to our new shape, our new parent function, the reciprocal function. All right. So come on back for 3.7 part 2.